Hi, I am MD Rabiul presenting the paper Self-supervised Learning for Reading Activity Classification, and we are from Osaka Prefecture University, Japan. In our daily life, we are doing different human activities, and reading is a cognitive one. It is an important source of information that includes reading plain text, answering MCQs, and many more. Therefore, by reading, we don't simply mean reading plain text only, but also solving problems by reading. By applying classifications such as reading versus not reading, reading quality classification, we can get very useful information such as amount of reading, quality of reading, and many more. This information constitute a useful feedback that enable effective mentoring that in turn improves motivation and reading habit. Therefore, reading is a part of human activity recognition that can be classified into physical and cognitive. For physical human activities such as walking, running, riding a bicycle requires significant bodily movements and has successfully been recognized by employing IMU motion sensors data. On the other hand, for cognitive human activities, there have fewer bodily movements and need to capture biological signals with different sensors depending on activities. Different sensors may need different treatments, and cognitive human activities may not be solved by applying the existing technologies of physical human activity recognition. Therefore, we are motivated to take reading activity classification as an example of cognitive human activities and to solve it by applying eye movement data. For reading activity classifications, researchers conducted few trials with classical machine learning methods by employing handcrafted features. But the limitations are the lack of accuracy and less in the wild applicability. Deep learning has solved such issues in various fields, but it requires large-sized leveled data, which is problematic to achieve in most of the fields because of various reasons. A deep learning technique called self-supervised learning can learn with small-sized leveled data. The proposed SSL method consists of self-supervised pre-training and target task training. In self-supervised pre-training, at first we apply data transformation to a large-sized unleveled sensor data and pre-train the base network by identifying pseudo-levels applied during data transformation. In target task training, we pre-trained the base network by fine-tuning it, employing a small-sized leveled sensor data by identifying target classes. We evaluated the proposed method on reading detection and confidence estimation on answering multiple choice question. The experimental setup for reading detection is shown here. We record accelerometer, gyroscope, and electrooculography data by employing EOG glasses, while the user was reading text in the wild condition. The experimental setup for confidence estimation is shown here. We record eye gaze by employing an eye tracker, while the user was solving multiple choice questions in the wild condition. The result of our experiment for both tasks of reading detection and confidence estimation are shown in this slide. For both graphs, y-axis shows the accuracy and x-axis shows the number of leveled training samples per class. The red line shows the result of the proposed SSL method. The blue line shows the result of a fully supervised deep learning method. The black line shows the result of SVM, and green line shows the chance rate. By analyzing results for both tasks, we can say that proposed SSL method performs the best for both reading activity classification tasks. Finally, conclusion and future work. The objective of our study is reading activity classification. We proposed an SSL method and evaluated it on reading detection and confidence estimation. And finally, we conclude that the proposed SSL method is always recommended to apply for both reading activity classification tasks. And in future, we need to improve the accuracy of the classification and to apply the proposed method for other reading activity classification tasks to check the generality of the proposed method. Thank you for your attention.